Hello students. Today we're going to do some more systems, but this time we're going to use radical and rational equations. Now on your notes, the very first one I want to change, and if you will change number 1 please to this. Y is equal to x squared minus 13 is the first equation. Y equals 2x plus 2 as the second equation. And yes, you could do this graphically and find the intersections, but here you're to do it algebraically. And so since they're both equal to y, we can set them equal to each other. And so I can say that that top equation is equal to the bottom equation. And it's obviously a quadratic because it's to the second power. So I'm going to subtract 2x and subtract 2 from both sides to get a 0 on the right. So we get x squared minus 2x, and a negative 13 minus 2 is minus 15 equals 0. Okay, now we've got this quadratic equation to solve. And fortunately, it does factor very nicely into x minus 5 times x plus 3. Again, negative 5 times positive 3 gives you negative 15. Negative 5 plus 3 gives you that negative 2. Then we use the zero product property, and we set each of these two factors equal to 0, and we solve for x. So in this case, x is 5, and in this case, x is negative 3. Now, we have the x values. We now need to plug them back into either one because they form some type of intersection, and we'll get the y values. So let's take where x is 5, and let's plug it in here. 2 times 5 is 10, plus 2 would be 12. So 5, 12 will be one of the ordered pairs. You could also put it here. 5 squared is 25. 25 minus 13 is 12. It works either way, but I always go to the simplest equation to deal with. Then over here, x is negative 3. So let's plug negative 3 in here. 2 times negative 3 is negative 6. Negative 6 plus 2 is negative 4. And again, if you wanted to do the same thing here, negative 3 squared is 9. 9 minus 13 is negative 4. So these are the two answers for number 1. All right, problem number 2. Again, we have a system of equations. This one is a rational equation. This is a linear. They're both equal to y, so we'll set them both equal to each other. And so we'll say that 10 over x is equal to x minus 3. Now, this variable in the denominator is a problem. We need to get it up in the numerator, so we're going to multiply both sides by x. Now, x over x is the number 1. So on the left side, we have 10. On the right side, you can use a distributive property. X times x is x squared. X times negative 3 is negative 3x. So clearly we're working towards a quadratic equation. We'll subtract 10 from both sides, and we have x squared minus 3x minus 10. And once again, this factors nicely into x minus 5 times x plus 2, because negative 5 times positive 2 is negative 10. Negative 5 plus 2 is negative 3. And using the zero product property, we set each of those equal to 0, and we quickly solve for x. So x in this case is 5, and here x is negative 2. So we want to form our ordered pairs. This is 5. I'll take that x value, plug it here, and either one will work. 5 minus 3 is 2. And again, I think you can see that if I'd put it here, 10 divided by 5 would have been 2. Similarly, we go with negative 2. Plug it in here. Negative 2 minus 3 is negative 5. So those are the two solutions to that particular system, and that's number 2. All right, students, with number 3, we have a system. One is a radical equation, square root of x plus 6. The other one is simply a linear equation, y equals x. Again, they're both equal to y, so we can set them equal to each other. Y equals y. Okay, we have a radical equation. I'd like to get rid of that square root, so we do that by squaring both sides of the equation. So on the left side, the square root of x plus 6 squared is x plus 6, and x squared obviously is x squared. Now, I could subtract the x squared here, but then I would need to get rid of that negative in front, so instead I'm going to subtract x, subtract 6, have a 0 on the left, and we have x squared minus x minus 6. And sure enough, this also factors. Two numbers that multiply to get negative 6 that also add to get negative 1. So that's going to be x minus 3 times x plus 2. Using the zero product property then, x would equal 3, and here x would equal negative 2. So we come up to do our ordered pairs. One of them, the x is 3. We put it right here. So if x is 3, guess what y is? Y also is 3. Or if x is negative 2, similarly y would be negative 2. And that's example 3. Okay, students, we're going to skip example 4 and let's go on to example 5. And I do want you to change example 5. Change, I believe it was a negative 5 originally. We're going to make that a negative 4. Now, we have not used function notation all that much. We typically think of y equals. It's basically the same thing, but this differentiates that this is the f equation, that's the g equation. It could be an h or a j, but this is helping us differentiate the two. But the question is, what value for x will work for them both? In other words, it's a system of equations we're trying to find a solution for. And let's see, does it ask only for the x values? Yes, only for the x values. So once again, we set these equal to each other to find out which value for x is common to both. I'd like to get rid of this x in the denominator, so I'll multiply both sides by it. X divided by x is 1, so on the left we have negative 4, and on the right we have x squared plus 4x. And now we're going to add 4 to both sides, so we got x squared plus 4x plus 4. And sure enough, this thing factors quite nicely into x plus 2 times x plus 2. We could call it x plus 2 squared because this is the graph of this will come down at one spot. Using the zero product property, we know that x value is negative 2. And that's example 5. All right, guys, for example 6, we're given a radical equation, and we're asked to write the equation if this thing moved left 3 and then up 9 from its present position. Now, you can do this in your head, but I prefer to have students graph it out first. So, for instance, we know that positive 3 is the smallest x value we can have that will make this become a 0. We can take the square root of a 0, but you can't take the square root of a negative number. So we know that it's going to start here at positive 3 and at down 2. So this is the original equation, more or less. So then we're saying, okay, well, how would we write an equation that would move this thing left 3 units and up 9? So in other words, what would move this thing come here? If we went back 3, we would be here at 0, wouldn't we? Well, how would we designate 0? We'll call this one f of x. Well, all you got to do is just put in that x. You could put x plus 0, but why would we do that? Now, we want to move 9 steps up here. We're at -2, so if we go up here to +7, we've marched up 9 steps. So in other words, this new equation will look like this. And so we'd call it f of x is equal to square root of x plus 7. And that would have moved this whole thing up 9 and to the left 3. And that's example 6. All right, students, here we are in example 7. And here we have a rational equation. And we're being asked how would we write the equation that would take this particular one and move it to the right 5 and down 1. Well, we want to start with our asymptotes. Our vertical asymptote, where it would be undefined, is at +3. So we'll call that +3. I like to label it. That's our vertical asymptote. The horizontal asymptote is at -3. And we'll call that HA. Ha. Now we know, roughly speaking, and where did I put the marker? Here it is. Roughly speaking, because it's positive, we're going to have a branch in the 3rd quadrant and a branch over here in the 1st quadrant. All right, that's this equation. Now, how do we come up with an equation that moves this whole thing right 5? Well, if the vertical asymptote is at +3 and I'm going right 5, I think you'll agree that that's going to end up at +8. And if we want to go down 1 and we're already at -3 for a horizontal asymptote, that's going to put us at -4 for this one. And so this new equation would look, I'm getting a little confused with all my lines here, like that is if I drew it correctly. But the point is that we're to come up with the equation. So we'll say that g of x, the new equation, would be 2 over, now instead of x minus 3, it's now going to be x minus 8, because we moved it right 5. And instead of -3 there, it's going to be -4 here. And that's example 7. All right, if you'll turn the notes over to the back side, we're going to skip examples 8, 9, and 10, and I want to get to the 2 word problems below. The first one says that we've got the height h of t of a baseball at t seconds after it is tossed out of a window, and we're given that particular equation h of t. And then we've got a boy, the ball's going out the window, a boy's down on the ground shooting a paintball gun to see if he can hit the ball as it's coming down. And that equation, it's a linear equation, is listed as, probably should be given a different designation, but that's fine. They call it h of t also. So we want to find out, will the paintball hit the baseball as it's coming out of the window? And if so, when and at what height off the ground? Now, as you might guess, what we're going to do here is we're going to do it on the calculator, and this simply is an intersection program. Now we're going to have to rearrange the windows to some extent. So if you would go to your calculator, or just simply watch as I do it here. Let me find out where my calculator is there. Now I went ahead and put in the 2 equations. The top one is the baseball, y sub 2 is the paintball. And we're going to go zoom 6. Okay, the red line is the paintball, and we can see it does hit it at some point. But we're going to need to go here and resize the window. And so what I'd like you to do is to resize this window to make a y max of 40. And we're going to down arrow till we get there. And type in 40. And that should be good enough. And so we can hit graph. Alrighty. So what we want to do is we want to find that intersection, because that, it looks like it's 1, 2, 3, basically 4 seconds. And I can't count the little hash marks there, but it's at height. So we'll find out with the intersection program. And so we go from here, we go second, calc, above the trace button, choose number 5, intersect. Okay, I need to move that cursor to the other side, so I right arrow, never up and down, it's either right or left arrow, till I get close. You don't have to be right on it, that's good, and hit enter 3 times. So sure enough, in 4 seconds, the paintball does hit the baseball, and it hits it at 15 feet above the ground. And that was problem 11. All right, students, the final example here, number 12, says that the revenue for a company producing electric components is given by that y quadratic equation there, where the x is the price in dollars. Revenue is how much money they bring in. Revenue is actually not profit, it's all the money they bring in, and then they have to take away the costs, and that gives you the profit. The cost for the production is given by that C equation, 60x minus 10, and we're to determine the price, in other words, the x value at which point the production breaks even, when costs equal revenue. And anything above that is their profit. Now let's look at the 2 equations. I've put them in. Notice, let's be smart. Since this is a standard form quadratic equation, that is the y-intercept. And so we have, the standard screen only goes up to 10, so we can tell already that we're going to need quite a bit more y max. But let's first look at the standard screen. Let's go zoom 6. And sure enough, now this is a linear equation, the cost one, and that's really going up high. And we're really not interested in any of negative numbers here. So in a second, I'm going to resize the window. I don't need any x min. I actually don't need all that x max, and just to pretty it up, I may make it the x max of 4 or 5. And I need probably at least 200 on the y max. So let's go over to the window again. And I'm going to make 0 for the x min. I'm going to make the x max 4. I don't need to mess with the scale. Y min, I don't, you know, I can leave that there. It's not a big deal. But Y max, I'm going to put in 200. We'll see that. I think that's going to work. And then we hit graph. Okay, sure enough. So this is their revenue model. This is their costs. That's where the 2 equal each other. So from this point in time to the right, they're making profit. We want to find what that point in time is. So we use the intersection program. We go second, calc, number 5, and we can just hit enter 3 times. 1, 2, 3, boom. So the price, and in fact, I said it wrong earlier. I was mentioning time. That's not, the x value is price. So basically, at $1.50 per unit of whatever they're making, they're going to break even. And if they increase the price to some extent, they're going to make more. Well, let's see, no. Well, I'm not quite sure how to interpret that at this point, given this thing. But at any rate, the answer for what we're trying to find is at $1.50 per unit right there. And that was example 12.